Okay, welcome Year 5-6 to a maths lesson for Friday the 12th of February, last one before half term. So arithmetic questions, again, don't spend too long, 5 to 10 minutes. Pause the video now and have a go. Okay, let's look at the answers. So 6,732 divided by 8, 841.5. 3,408 take away 573, 2,835. 50% of 2,350, 1,175. 60,100 take away 900 is 59,200. 14.4 take away 6.59 is 7.81. 1/4 times 1/6 is 2/24. We might have simplified it to 1/12. And 309,712 take away 69,087 is 240,625. And 70% of 250 is 87.5. All right, today we are continuing to look at area. So if you remember from yesterday, area is the amount of space that a shape, a complete shape, takes up, and we measure it in squares. So we are actually thinking of the number of squares that that shape is taking up. And the number of squares that it's taking up depends on the size of the squares and depends on the length, and then we can work it out from the length and the width of the shape. What we're doing today is we're looking at compound shapes. So a compound shape is a shape which is made up of two or more shapes. So here we've got this kind of rectangle plus this square. And if we put them together and we pretend that that line wasn't there, we kind of wanted to get rid of that bit. So if we pretend that this line here wasn't there, then we've got kind of the shape goes around here, so down here and across, there, to there, to there, and to there. So there's our shape. So it's made up of the rectangle and the squares. This one down here is kind of, you've got the rectangle. Here, and then you've also got a triangle here as well. So it's made up of two shapes. So how then do we find the area of compound shapes? Well, if we look at this one here, we've got effectively two shapes, because what we can say is that there are two rectangles making up this shape here. It's a compound shape made up of two regular shapes that we know. So we've got one rectangle here, and we can kind of pretend that there's a cutoff here. So we've got one rectangle here and one rectangle here, which means we can think of the area of this rectangle separately from this rectangle and then add them up together. Obviously for this one at the moment it's quite easy because you can just count up the squares, which will tell you the area. But for the questions we're going to be doing, we need to start thinking of it as two separate shapes, which we could work out and calculate the area of the shapes separately so that we can add them together. So if we just imagine this was a shape here, it would be 2 centimeters in kind of the width and 1, 2, 3, 4, 5 centimeters in the length of it here. And this shape would be 2 centimeters and 1 centimeter. So 5 times 2 is 10. So this area here is 10 centimeters squared. And then 2 times 1 is 2. So we've got the plus the 2 centimeters squared of this shape here. Add them together and we get 12 centimeters squared, which is the answer for the area, and because the number of squares is 12. But we're trying to think of it as two separate shapes that we need to add together to then find the total area that this compound shape is covering. So here we go, another one then. So here we've got two separate shapes, no squares this time. So we need to think about them as separate shapes, but together they are making up one shape. So again, if I do the outline of this single shape, is the red line here. But then we've got this blue line, which we can think of as kind of the cutoff between the two separate shapes. So we've got a rectangle here and a rectangle here. So we can do the area of this rectangle. 6 times 5 is 30 centimeters squared. This one here. And shape B, this rectangle, is 2 times 8. 2 times 8, which is 16 centimeters squared. And then if we add these two areas together, we get the total area of this shape being 46 centimeters squared. Okay, with this one, we've got 3 separate shapes. So this time there's 3 separate shapes. So we would have to think that I've got one rectangle, kind of this B rectangle in the middle here. But then I've also got another rectangle here, and there's a cutoff there, and another smaller rectangle here, which I can kind of cut off there. But altogether, the shape would have started with something that looked a little more like this. And then you have to break this shape down into the smaller shapes. You have to think of it as the whole shape first, and then you have to think, how do I break this down into smaller rectangles or smaller squares that I could find the area of? So you could find the area then of this A by doing 6 times 3, 18. Find the area of this B, how? Well, you've got 5 times 7, because this is 6 here, this is 1, which means the leftover in here is going to be another 7 in there. And then we've got 3 times 1 for this area here. Sorry, no, hang on. The 7 is the 4 down here plus the 3 here. So we know that from here to here is 7, and this is the 5 across the top, because it's the 12 in total, minus the 6 and the 1, which leaves the 5 across here, and then the 7 down here. Thinking about the working on the perimeter when you were finding those missing lengths yesterday, you've got the 4 plus the 3 makes this length here. So then you've got 7 times 5 to get your 35. And then this last one, you've got 3 here, and 1 there to get the area of 3. And then you need to add all those up, the area for each shape, and in this case you'll get 56 centimeters squared. This one works slightly differently, because instead of thinking of it as separate shapes that you're adding together, which you could potentially do, this one you're actually extending the shape and thinking of it as a larger shape to begin with, and then subtracting the part that is missing. So we are pretending that this entire rectangle is complete and that there isn't a missing chunk here. So first we're pretending that this entire rectangle, and we're finding the area of this entire rectangle, assuming that this was closed off here and there wasn't this bit missing. So to find that area, we do 8 times 6 to find the area of this rectangle, which would be 48. What we can then do is, if we're given the information, we can subtract the area that is missing. So we know that this area here, this blue rectangle here, is actually missing from the shape. It's been cut out. And we know its area because we know that it is 4 meters times 3 meters. So we know this area is 12. So if we subtract, take out that cutout area from the 48, we end up with 48 centimeters squared, take away 12 centimeters squared. Okay, one more. So have a go at this one. Pause the video and see how you get on. Okay, so hopefully using all the information, even giving you the answer as well, you've been able to kind of work out how it was done. So you've got the three different shapes that you had. So we had shape A, which was this smaller shape here, which is 5 times 5. And then you were able to work out that that was 25. Then you've got this area here, which is the B shape. So that is 3 times 15, because this whole length here is 15. This length here is 15, so it's 3 times 15, which is 45. And then this area here, C, is 4 times 5, which is 20. And then you added them all up. Okay, time for you to have a go at some questions now. So we'll start with the silver ones. So it's given you the separate shapes so that you can work out the separate areas, and then you need to work out the separate areas and then add up the areas at the end to work out the total area of the compound shape. So work out A first, then B, then add them up to find the total area. With this one over here, you are working out the area of each of these shapes without it being broken up for you. So you need to think, where are the two separate shapes that you could work out separately before then adding it together to find the total area of the compound shape. So break it into like an A and B, like all the questions we've looked at. Break it into an A shape and a B shape. Work out the area of the A shape and the B shape, and then add them together to find the total area, which will be your final answer. So pause the video and attempt these questions. Okay, with this one, we got 4 times 3, which was 12. And then the area of this one was 5 times 2, which was 10. And then add those together and you've got 22 centimeters squared. With these ones, you wanted to break the shapes up down here and then across here, because you're given the information to work out the separate areas. So you've got kind of an A there and a B here, and an A and a B there. So you could work out this area here, 12 times 4, which is 48. And then here B is 8 times 3, which is 24. So you add those together and you get 72 centimeters squared. These two shapes, you've got A up here, 7 times 4, which is 28, and B 3 times, well, you take away the 4 to find the side here. So 9, 5 down here. So it would be 3 times 5, which is 15, and then add the two together to get 43 centimeters squared for that one. Okay, with these two, there you've got a few different options. So hopefully one of the options you have might be the answers we've got, but don't worry if not. You've got a few different ways you could solve these questions. So how many different ways can you split this shape to find the area? So think of different ways you could split up this shape. And Jack says this shape has an area of 34 centimeters squared. Show that Jack is correct. Find 3 more possible compound shapes that have an area of 34 centimeters squared. So here, you're creating your own compound shapes, which are different to this one, which have an area of 34 centimeters squared. So you need to find 3 more of those. So pause the video and tackle these goal questions. Okay, so how many different ways can you split this shape to find its area? So one possible solution would be you can split it like this here, make this a bit bigger. So you've got kind of thinking of this as a separate A here. And then this across here. So there's A and B across there. And we know that from here, you can cut off that and cut off that there. We know that this is going to be 6 across here. And so we could break it down. So on this one, it made it 8 on this one across there. So it says you can change the values. So you add the values and add the different lengths where you wanted to find the different areas of the shapes. So you could have added, so it added another 1 meter, said that length there is 1 meter. So you're adding your own values to try and work out the areas and find different areas of how you could split this shape up. That's what I was trying to get you to do. And then this one, so you were showing how Jack was correct and then trying to have a go at creating your own ones. So hopefully you worked out the separate areas for this one, so you could have split this one off potentially across, let's say, there and possibly there, and then calculated it out to find 34 centimeters squared altogether. So what you could do is actually, instead of that one, we could do so we could just do this bit here. So we could do 2 times 5, so that would be 10 centimeters squared here. And if we know this bit is 5, but all down here is 8, it means that we know the size of this bit has got to be 3 centimeters. So from here down to here has got to be 3 centimeters, because down to there is 5, plus the other 3 would be the total length of this here. So if we know that, we could actually, we don't even need to do this bit. We could do across here, potentially. So we could do 4 plus the 2, means we know that all across there is 6 centimeters. So we could do 3 times 6, which is 18 centimeters squared. And this bit here, we know it's 2, and we can take off that 3, which means we know from here to here will be 3 centimeters squared. So 2 times 3 is 6 centimeters squared for this little area here. And then if you add those bits together, you have a total area of 34 centimeters squared. There might have been other ways you could have done it as well. And then creating your own one, this is another example of a shape, which is a compound shape, which is 34 centimeters squared. Okay, and then finally the platinum questions. So pause the video again and have a go at these. Okay, so some compound shapes for you to solve. So this first one, A, it kind of gives you the width here, and hopefully maybe you took out this chunk here, potentially, one way of doing it. If it's giving you this 4 here, and you know that that bit is then the rest of the, to make up to the 10, so that's going to be 6 up to there. Plus you've got the 7 and the 7 there, which is 14, and then you can find the length of this bit here. So this bit you might have taken out to find out that one, and altogether hopefully you got 184 centimeters squared. And then these 2 bits as well, you might have taken out these chunks. So think of it as a whole shape, then find the area of these 2 little bits, because you've got some information about what this central bit is, how long this bit is, and then take out those chunks, and then hopefully you got 204 millimeters squared. And then this one, the area of the shape is 83 centimeters squared. Work out the perimeter of the shape. So we know that the area is 83 centimeters squared, which means you can then use that to find out the total perimeter. So what you might have done is then extended this over to here to find out what that would have been. So what times 12 equals 83. And then what you could do is think about what chunk you would have taken out here to then find this kind of missing area that you take out, which would then give you the lengths of those sides as well. So what I could do is think about the fact that this side length here, so instead of taking out that bit, I don't think that's going to work. So instead we need to find what this length is here. So I know that from here to here is 7. So the rest of this from here to here will be the rest that makes up 12. So that's going to be 5 centimeters. So what we can then do is, instead of cutting the shape this way, we could cut the shape this way, because then we can find the area of this part here. So that's going to be important in a second, because if we can find the area of this part, we know that 7 times 4 is 28. So if I get rid of this, we're not going to do it that way. We're going to find the area of this part here, which is 28 centimeters squared. So why is that important? Because that then allows us to work out the area of this part here. The total is 83. We know the total shape is 83, but then we know we can work out what this area is by doing 83 take away the 28 centimeters squared. So 83 take away 28 is 55 centimeters squared. So this area here is 55 centimeters squared. Now, how does that help us? Well, if I know that this length here is 5 centimeters, and I know that the area of this part here is 55 centimeters squared, what I can do is then use that information to find out this length here, because 5 times something equals 55, which means that that length there has to be 11 centimeters, because 11 times 5 equals 55. What that then means is that we can work out the length of this side here. By doing 11 take away the 4, which means this length here would have to be 7 centimeters as well from here to here. So hopefully, if we add all these up, so 11, add 5, add 7, add 7, add 4, add 12, gives me 46 centimeters, which hopefully, yes, is 46 centimeters. So hopefully some of you managed to solve that one as well. So well done, everyone. Thank you for all your hard work over the maths over the last couple of weeks, and have a great rest over half term, and we'll see you back then.